Hello everyone. Today I'm going to present my seminar to topic TLC NAND flash memory, which is used widely in SSDs, USB drivers, SD cards, and other modern storage devices. So I will explain how TLC NAND works, its structure, application in modern electronics, its challenges, industry importance, and its future scope. Here goes with the introduction. So TLC NAND stands for the triple level cell NAND flash. It stores 3 bits per cell by using 8 distinct voltage levels. This makes it a non-volatile and high-density storage technology commonly used in SSDs, SD cards, and USB drivers. The main reason TLC is so widely used is because of its low cost per GB and large storage capacity. As modern applications like 4K or 8K video, AI, IoT, and cloud computing generate huge data, we need storage solutions that are compact, affordable, and energy efficient. So here comes the TLC NAND, effectively balances performance, capacity, and cost, which is why it has become the most dominant memory type in smartphones and consumer electronics. Here you can see how this SLC, there's a difference between SLC, MLC versus the TLC bits per cell. So also I'm going to explain like there is why and there is a much needed importance in the current industry. In today's digital world, storage is the backbone of everything from smartphones and laptops to IoT systems and cloud platforms. Companies require storage technologies that give high density, low cost, low power usage, small physical size. TLC meets all these requirements compared to the older memory types. TLC stores more data in the same chip area, allowing manufacturers to produce high capacity devices like 128 GB and 256 GB phones at affordable prices. This makes TLC extremely important for the current semiconductor and electronics industry. So here are some objectives of the seminar that I'm going to discuss in the further slides. So the objectives of my seminar are to explain the structure and operation of the TLC NAND flash, to compare SLC, MLC, and TLC memory technologies, to discuss TLC's application in modern electronics, to analyze its challenges, include endurance, retention, and errors, also to understand the industry trends and the future scope of the TLC NAND. With these objectives, I am going to give a complete understanding of how TLC works and why is it important today. So here is why is it important today. I have also mentioned it because we are living in an era of smartphones, IoT, and cloud computing. Storage is the backbone of everything, and digital. Industries needs a balance between performance, cost, and space efficiency. Here is the voltage allocated to each stage based on the NAND flash technology. In different, there is a 1 bit cell, 2 bit per cell, and 3 bits per bit. And here also TLC NANDs is the that standard. So next, we're going to talk about the technical background and how this TLC NAND flash works, the core principles and the working mechanism of it. So TLC NAND flash is built using floating gate MOSFETs. Each cell stores data based on how much charge is trapped inside the floating gate. So since TLC stores 3 bits per cell, it requires 8 different threshold voltage levels, as we have seen the earlier. Because these voltage levels are very close to each other, precise programming are and reading are necessary. So the key components of TLC NAND includes the memory cell array, that are millions of MOSFET cells, sense amplifiers that detect small voltage changes, row or column decoders select specific cells, page buffers hold temporary data during read and write operations, and ECC, the error correction code, ensures data integrity. So the working principle is simple, that is, more electrons stored, higher voltage represents different 3-bit combinations. Next comes, so what makes the TLC stands out that much in the going industry needs. So first reason is the high density, stores more data in the same silicon, cost effective, low cost per GB, ideal for the consumer devices. So here you can see the SL, there's a feature differences in SLC, MLC, and TLC, and here also the TLC is standing out in every aspect: bits per cell, write speed, and endurance, cost, and the main reasons are the cost effectiveness and the uses that are doing in the current industry needs. So this is the working of the NAND flash memory with 8 different charge levels. So there is obviously a huge difference between the SLC and MLC. Here you can see the comparison image as well. So there comes the internal architecture of the NAND flash, that how it is built, how these things are done. So NAND flash is organized in a hierarchy, and it is divided into blocks and pages. Contains block contains pages and pages contains memory cells. So data is programmed page by page and erased block by block. TLC requires high precision because 8 level voltages are very close to each other. So talking about the core operations, so reading and programming preferred to perform to the page level, writing to the existing data before new data can be written to a page. The entire block containing that page must first be erased. And talking about the erasing part, a block level operation, all pages within the block are erased and reset to a logic state of all one is. And the garbage collection. So what happens is the flash transition layer when handles the programming, erasing, garbage collection and the water leveling. Because TLC uses 8 voltage levels, it needs higher precision for both programming and as well as reading. This increases completely complexity but enables high storage density. Here you can see the NAND flash block page architecture, like how this is worked. There comes the applications. So here are huge applications talking about, we're going to talk about some few in this. So TLC is used everywhere due to its affordability and high capacity. It is widely used in consumer electronics, smartphones, tablets, digital cameras, smart TVs, and these devices requires compact and inexpensive storage. Next is the storage devices. SSDs, use USB flash drivers, SD and micro SD cards. These are rely heavily on TLC because users demand high capacity at low cost. Healthcare devices, portable diagnostic system, patient data loggers, medical imaging equipment, because embed ensures quick access and secure storage of the patient data. And last but not the least, communication and the networking. So used in routers, IoT gateways, and edge devices to store firmwares and logs. And so I can say, so these devices stores logs, firmwares, and temporary data using TLC. So also there is societal impact and SDG. That yani we can say that our TLC NAND not only done in technology but also in the SDGs, also support the sustainability very much. Energy efficient storage, SSDs consume less power than HDDs, reducing carbon footprint, longer device lifespans. Reliable flash storage enhances durability of electronics, minimizing e-waste. Also enables data-driven healthcare and education by powering compact devices in remote areas. So here are the SDG goals that it completes. First is the good health and the well-being, affordable and clean energy. Ninth one, the industry innovation and the infrastructure drives digital story and information in tech industries. And last but not the least, responsible consumption and production, that is more durable electronics, reducing e-waste. So hence, TLC not only supports technology but also contributes for sustainability. So here I can conclude my PPT. So TLC NAND is the most widely used flash storage in consumer electronics. It provides the best balance of cost, capacity, and performance. Despite challenges like lower endurance and higher error rate, modern SSD controllers and 3D NAND technology have made TLC reliable and efficient in today's technology. With increasing demand for digital storage, TLC will continue to be the backbone of future storage solutions, especially for smartphones, IoT devices, and cloud storage. So here are the references that I have used for making all this PPT, all the references, all the things that I've mentioned in the PPT. So thank you everyone.